Hello everyone, this is Dr. Daya Sagar Chowdary, Senapati, Assistant Professor, Department of Electronics and Communication Engineering, Aditya University, Surampalem. Today I would like to discuss about the concept T flip-flop. So coming to the learning outcome, at the end of this lecture, students will be able to understand and design sequential circuits using T flip-flops for toggling, counting, and frequency division applications. Now, these are the types of flip-flops. So we already discussed all these flip-flops like SR flip-flop, JK flip-flop, and D flip-flop. Now we will discuss about the T flip-flop. Simply T, we call that one as a toggle flip-flop. Now, a T flip-flop, or simply we call this one as a toggling condition. That is why toggle flip-flop is a sequential circuit that changes its output state whenever the input t is equal to 1 and a clock pulse is applied. When t is equal to 0, it retains its previous state. So, if we consider these two block diagrams, that means if we consider the first block diagram, most of the time we call this one as a that just JK flip-flop is simply modified to T. That is why JK to T flip-flop. That means both the inputs J and K inputs are directly connected to one terminal, and the terminal is the input. We call that one as a T input. So that is why, and the second, if we consider the second block diagram, the T input is the single input, that is nothing but the T, and as usual the Q and Q bar is the outputs, and as usual our clock signal is the controlling signal. Here clock is enabled at the time. Here CLK we defined, and the two. So here we mentioned this one as a angle. That means this is a edge triggered clock signal, edge triggered flip flop. We call this one as a edge triggered T flip flop. Now, so this is a simple. Whenever the input T is equal to 1 and clock pulse is applied, the when is equal to T is equal to 0 and previous state. So we will observe all these conditions in the next slides. So simply this JK is modified into T. Now coming to the circuit diagram, this is the circuit diagram. If we observe the circuit diagram, so now here it contains three flip-flops. Likewise, see, if we consider this dotted line is nothing but the SR flip-flop. Now the SR flip-flop is directly converted into JK. That means again there is an additional circuit that is added to the SR flip-flop. That is nothing but finally we will get the JK flip-flop, and when both the inputs, that is J and K, are connected to single input, if we apply that single input, we call that one as a T. Now that means the input is T. Now the entire flip-flop is converted into T flip-flop, that is toggling flip-flop. And the clock signal is as usual, we can connect the clock signal to both the NAND gates, that is this NAND gate and this NAND gate, and finally the entire circuit is drawn as usual. Now coming to the characteristic table, or we call this one as a truth table. Now whenever the clock signal is enabled, that means when t is equal to 0 condition, whatever the present state, that is we call that one as a QN state, whatever the QN state, present state, the same, the next state is also simply follows the present state whenever clock signal is enabled. And again the clock signal is enabled whenever t is equal to 1, the output, which is nothing but Qn plus 1, that is next state, simply which is nothing but the quite opposite. That means we call this one as a, if the output is 1, that means the Qn is 0. If the Qn plus 1 is 0, that is 1. So this condition we call that one as a toggle condition. That is why this flip-flop we call that one as a T flip-flop, toggle flip-flop. Now, so these are the four cases. So according to the excitation, is the characteristic equation. This is case 1. When t is equal to 0, the flip-flop does not change its states. Hence, Q and Q bar retain their previous values. We call that one as a hold state. And coming to case 2, when t is equal to 1 and a clock pulse is applied, then the flip-flop toggles. That means if the previous output Q is equal to 0, then Q becomes 1 and Q bar becomes 0. And coming to the case 3, when t is equal to 1 and the clock pulse is also applied, that means that it is enabled. If the previous state previous output, we call that one as a q is equal to 1, then q becomes 0 and q bar becomes 1. So toggle condition. Again, case 4, the T flip-flop has no invalid condition. It either holds the previous state when T is equal to 0 or toggles the output when T is equal to 1. Now, coming to the characteristic equation. So, characteristic equation, that is, this is the characteristic table. So, before going to characteristic equation, so we have to consider the characteristic table. Now, we have to find out the Qn plus 1. Qn plus 1. Now, wherever the Qn plus 1 is enabled, that means in these two cases, the output is 1. So, now the output is 1 means we have to consider the two corresponding inputs. Now, with the help of this corresponding two inputs, we can construct a K-map. Now, the K-map is like this. Now, two inputs, that means totally here 4 boxes we have to draw. And so, for 4 boxes, these are two inputs, T and Qn. So, T and Qn means there are two inputs. So, 2 to the power of 2 is equal to 4. That is 4 boxes we have to draw. Now, 4 boxes. So, 0 one time and 1 one time. And T is equal to 0 one time and 1 one time. So now 0 0, that is 0 box, 0 1, that is 1 box, and 1 0, that is 2 box, and 1 1, that is 3 box. Now, so these two conditions, the output is enabled. That means Qn plus 1 is enabled. Now, so when T is equal to 0 and Qn is equal to 1, that means T is equal to 0 and Qn is equal to 1. So this condition, so we have to place 1 here, and here second one we have to place T is equal to 1 and Qn is equal to 0. That means T is equal to 1, this is T is equal to 1 and Qn is equal to 0. Then this is 1, we have to place 1 here. That means that is 1 box. So we have to place 1 here. That means these two ones are we placed. And now we cannot group these two ones because it is having K-map is having certain rules. So we cannot group these two ones. Now the grouping is like singular. So single ones we have to group here. Now for this particular one, the term is T Qn bar, because this is represents T is, that is 1, T is in 1 and Qn is in 0. That is why T Qn bar, and this term indicates T bar and Qn. That means T bar means T is in 0 and Qn is in 1. That is why T bar Qn. So Qn plus 1, this is the characteristic equation of this particular T flip-flop, toggle flip-flop. So Qn plus 1 is equal to Qn bar T plus Qn T bar. So this is the characteristic equation. So now coming to the advantages of this particular T flip-flop. So this design is very simple. That means simple design, uses only one input because J and K inputs are connected to single input. We call that one as a T input. And now making it easy to implement. And toggle operation. So automatically toggles output when T is equal to 1. Useful in counters. So widely used in binary counters and frequency dividers. And low hardware requirement. That means requires few logic gates, and easy conversion can be obtained from JK flip-flop by connecting J and K input terminals to directly 1. Coming to the disadvantages, so it is having limited functionality, so which performs the only toggle operation and not suitable for complex control, cannot be directly implement set or reset operation condition because only one input is there. If we apply 1 means both input will, that means two inputs will get only 1. If we apply single input, that is 0, means the JK and both inputs will get 0. So that is why we cannot give the other set and reset condition, so which is not suitable for that complex controls. And propagation delay, coming to delay increases in cascaded flip-flops. That means if we increase more number of flip-flops in cascade, so the delay is also more. That means we call that one as a propagation delay. So needs clock signal. Definitely the input is only one, that is T. Definitely it requires the clock signal CLK, and outputs are Qn and Qn bar or Qn plus 1, the next state. And so requires proper clocking for correction operation. And coming to the applications, so binary counters most of the time used in asynchronous and synchronous counters. Frequency divider circuits, so divides clock frequency by 2. So mostly it used in frequency divider circuit, so that means divides clock frequency by 2. So most of the time this is a circuit, so this T flip flop is used in divided by 2 circuit. That means if we consider this clock frequency, that is, so if the clock frequency is like this, the clock signal is connected here, and at the same time the output is connected to input with the help of one inverter. That means Qn is equal to T. So we can consider this circuit as a divided by 2 circuit. Most of the time this divided by 2 circuit, that means this divided by frequency circuit, frequency divider circuit is used in the all the devices like our mobiles, our laptops, everything. And toggle switching circuits, so used in most of the time on or off control applications. And digital clocks, so used in timing and counting circuits, because we require 0 and 1s and 0 1 ones like this, every time it is switching. So for that reason we are using this toggling condition. And used in control logic, so used in simple state machines. Most of the time state machines require this type of flip flops, that is T flip flop. Coming to the summary, the T flip flop is a simple toggle based sequential circuit that changes its state when the input T is high. It is widely used in counters and frequency divider circuits due to its simplicity and minimal hardware requirement. However, its limited functionality restricts its use in complex sequential circuit designs. Thank you.